In this lesson, we'll be using a formula method to determine something that is called underload. Underload is defined as the difference between the allowable traffic load and the actual traffic load. Practically, it represents any spare capacity that may be available for loading onto the aeroplane at the last minute, without any limitations being exceeded. To calculate the underload, it is necessary to first calculate the maximum allowable traffic load, then calculate the actual traffic load for the flight, and subtract one from the other to give the underload. A reminder of the definition for traffic load and the formula for underload can be seen on screen. Before we can determine the underload, we have to first calculate the limiting allowable traffic load. 4 formulas are used, and the lowest of the 4 solutions of structural, takeoff, landing traffic load and taxi ramp mass will be the allowable limit. The 4 formulas on screen must be learnt and recalled when required. Note the 4th will only be limiting if the taxi fuel is greater than the difference between the maximum structural ramp mass and the maximum structural takeoff mass. A golden rule to follow when using the formulas is to first determine both the takeoff fuel mass and the fuel remaining on landing. On screen, you will see an example of obtaining the required fuel data. Starting with a block ramp fuel of 32,200 kilograms, we now subtract the start taxi fuel of 500 kilograms. This gives us a takeoff fuel of 31,700 kilograms. The trip fuel is 9,000 kilograms, and we must subtract this from the takeoff fuel, which gives a fuel remaining of 22,700 kilograms. Let us now work through a complete example of calculating the underload using the formula method given all the relevant data. A table of all the necessary data is shown on screen. To make it easy, we will do this in 3 steps. Step 1 will be the golden rule of working out the fuel state, followed by Step 2, the limiting traffic load, which includes the dry operating mass, and finally, Step 3, the underload. For the first step, we must apply the golden rule of working out the fuel state first, and this is done by constructing a table of the fuel data, starting, in this case, with the block ramp fuel of 12,900 kilograms. Now enter the start taxi fuel of 400 kilograms and subtract it from the block ramp fuel, which gives the takeoff fuel of 12,500 kilograms. The trip fuel of 9,500 kilograms must be subtracted from the takeoff fuel of 12,500 kilograms. This gives us a fuel remaining on landing of 3,000 kilograms. Before we can find the limiting traffic load, which is step 2, we must know the dry operating mass. We can use a formula for this from our previous lesson on definitions, which is operating mass equals dry operating mass plus takeoff fuel. Changing the formula around, the dry operating mass equals operating mass minus takeoff fuel. Extracting the operating mass of 47,500 kilograms from the data table and subtracting the takeoff fuel of 12,500 kilograms gives us a dry operating mass of 35,000 kilograms. Now we can proceed with step 2 to construct a table and use the 3 formulas to find the maximum allowable traffic load. In the table at row 1, enter the maximum zero fuel mass of 52,000 kilograms and subtract from it the dry operating mass of 35,000 kilograms to equal 17,000 kilograms. Now we can enter in row 2 the regulated takeoff mass of 63,500 kilograms and subtract the dry operating mass of 35,000 and the takeoff fuel of 12,500 kilograms, which equals 16,000 kilograms. Next, we can enter the details in row 3, the regulated landing mass of 57,000 kilograms, and subtract from it the dry operating mass of 35,000 kilograms and the fuel remaining on landing of 3,000 kilograms, which equals 19,000 kilograms. Looking at the 3 maximum allowable traffic load calculations, we can see that the lowest mass of 16,000 kilograms is the limiting allowable load. We can now extract from the table the data which will make up the actual traffic load. The actual traffic load is the sum of the passenger load mass, 11,760 kilograms, the baggage, 1,820 kilograms, and the cargo, 500 kilograms, giving a total mass of 14,080 kilograms. Finally, we have all of the information to complete step 3, calculating the underload, which is the actual traffic load of 14,080 kilograms subtracted from the allowable traffic load of 16,000 kilograms, which gives us an underload mass of 1,920 kilograms.